Hello, my name is Sam Hankley. I'm a junior at UNC Chapel Hill and currently majoring in neuroscience. So yeah, just on the pre-med track and would like to apply to Chapel Hill Medical School. So that's a little bit about me. I also really like to mountain bike and hike and generally be outside. So yeah. Um, so the reason why I would like to be a chemistry mentor is because I really do enjoy tutoring and being able to teach the material that you kind of recently learned. I've tutored a lot all throughout high school. And so, yeah, I think it's just really rewarding to be able, and it really does, as a more selfish reason, it really does solidify my own understanding of what I learned. And in particular, I would like to peer mentor for Chem 262. Um, and so in terms of how to develop better study and learning strategies, I think I would mainly want to encourage my peers to adopt Anki, because I think that really uses a lot of good techniques, good study techniques in one program. For instance, it makes you or it allows you to use flashcards that you can make on your own, and so that really forces you to use active learning as opposed to passive learning, which would just be rereading your notes, rewatching lectures, which don't have they aren't without their merit, but they're definitely not as effective as active learning. So by using Anki, it kind of forces you to use active learning, which is good. And it has the benefit of having built-in spaced repetition programs in it. And so basically that, which is kind of a bit of a rabbit hole behind that, but it kind of shows, I think the research has shown that spaced repetition um, with active recall is like a very effective evidence-based study technique that I think a lot of medical students actually use um, in medical school, obviously. So I think the stressing and kind of maybe teaching them a little bit about how to use Anki, maybe how to use certain extensions like image occlusion, which would which would allow them to make flashcards very quickly from directly from the resources that they're given, like lecture videos or lecture PDFs. So I think that, and also just telling them about Anki would enforce those good study habits of using active learning, pacing yourself, using spaced repetition, etc. So now let's see if I can move on to this prepared problem. Let's share my screen. And let's go over to this problem. So this is from midterm 3 that I had in spring 2022 for Chem 262. And so it's asking to rank the order of increasing basicity of the carbonyl oxygen, which would be the one that has the double bond attached to it. And so the way that I would begin to go through this problem would be that in order for something to be basic, what are some of the properties that it would have? Well, it could have a negative charge. None of these have a negative formal charge. But another property would be that it would have a lot of electron density. So here we can see these carbonyl oxygens do have electron density, and it can be made even more apparent that they have electron density, that, for instance, structures 1 and 3 have electron density when we draw in the corresponding resonance structures. We'll do an abridged version just to be quick. And so I think that would be one thing I would stress in this problem, and maybe in a lot of problems in general, is that drawing resonance structures, even if they're really quick like this, can be really helpful to solve a lot of these problems. And so 3 would look like this, except instead of an N, we would have an O. Instead of a nitrogen, we would have an oxygen attached to there. And so to address this problem, I think the first thing that you could recognize is that Okay, structures 1 and 3 have electron donating atoms. Sorry, this should be from the nitrogen. Have electron donating atoms adjacent to the carbonyl oxygen, which can, through resonance, donate electrons to that carbonyl oxygen, as shown in this resonance structure down here. So I think that logic already tells you that 2 must be the least basic carbonyl oxygen because it doesn't have electron density from resonance. The alkyl groups can donate a little bit, perhaps, but not nearly as much as through resonance. So that would tell you that we can already limit our answers to C and D. And then when we look at the difference between C and D, we can look at, okay, if this was an oxygen, we're essentially saying for either it's 1 or 3, it's, well, this atom here doesn't matter if it's a nitrogen or an oxygen. And it actually does, because the oxygen is the oxygen is more electronegative than the nitrogen. And so what does that tell us? Well, that tells us that this interaction here of donating electrons through resonance is less likely to occur because the oxygen is more electronegative. It's less likely to want to give up its electrons. And so nitrogen, on the other hand, is less electronegative, which would be more willing to give up its electrons through resonance. So that could tell you that 1 is more basic than 3. And so the correct answer would be D, 2, 3, 1. So anyway, that's my shtick with that problem. And yeah, I think this is my video, and I really hope that I get to see you guys as a peer mentor for fall 2022. Thank you.